inner core or inner shell of the electronic configuration of p block elements may differ. Along a period, there is a progressive increase in the effective nuclear charge of the atoms while electrons are added to the same outermost shell. Ionization enthalpy of p block elements increases along a period and decreases down the group. The ionization energies of boron series of elements decreases or moving down the group. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Today we are starting up a new chapter, that is some p block elements. Okay, let us see first the exam corner. The number of hours required to complete this chapter is 8 hours. In the question paper pattern, as we know, there are 5 parts. In that first part A, that is 1 mark carrying questions, there are 2 questions will be given. In the part B, that is 2 mark carrying questions, 1 mark will be given. In the part C, in the question number 26, 1 question is given. So overall 7 marks is allotted for this chapter. Let us see what all the contents we'll discuss in this session. First, general introduction, group 13 elements. From that group 13 elements, properties of boron family elements. The elements having ns2np126 except helium valence shell electronic configuration are classified as p block elements. In the periodic table, the right side of the block will be considered as p block from the group number 13 to 18. Its electronic configuration ns2np126 means p can have 1 electron, 2, 3, 4, 5 or 6. 6 is the complete shell electronic configuration of p. S is already completed except helium, that is okay. The elements of group 13 to 17 are, and the noble gases 18 or 0 group constitute this category of elements. The p block elements are grouped into group 13, 14, 15, 16, 17, 18. Group 13 boron family, group 14 carbon family, group 15 nitrogen family, or it can be called it as pnictogens. Group 16 oxygen family, chalcogens, group 17 halogens, group 18 noble gases. This boron family, why means the starting element from top to bottom, group 13 in the group, that first element is boron, so boron family. Next carbon, carbon family. Next nitrogen, nitrogen family. Oxygen, oxygen family. Like this, overall 6 groups are there in p block. Next, atomic and ionic radii. The variation in properties of the p block elements due to the influence of d and f electrons in the inner core of the heavier elements makes their chemistry interesting. What they are telling? The variation in properties of the p block. There are much variation in p block elements due to the influence of d and f electrons. Here, in the p block elements, d electrons and the f electrons will get interfere. Due to that influence of d and f in the inner core of the heavier elements, the property of this block will get interesting. The inner core or inner shell of the electronic configuration of p block elements may differ. The electronic configuration of the inner shell electrons, which is having the heavier elements, it will be differ. The difference in inner core of elements influences their physical and chemical properties. Due to the difference in the inner core of elements influencing, the properties of the elements also get differ. Consequently, lots of variations in properties of p block elements are observed. Atomic and ionic radii of p block elements decrease on moving from left to right and increase from top to bottom in any group. We know that atomic size or ionic radii will get decreases from left to right and will get increases from top to bottom of periodic table. Along a period, there is a progressive increase in the effective nuclear charge of the atoms while electrons are added to the same outermost shell. Due to the atomic size and ionic radii are decreased along the period, the effective nuclear charge will get increased. How means, the what all new electrons are getting added, that will be added to the same shell. So effective nuclear charge will be more. This causes a decrease in atomic size from left to right along a period. Due to the effective nuclear charge is high, the atomic size is getting decreased. Down a group, the effective nuclear charge decreases due to addition of new shell, and this results in an increase of atomic size. Down a group, effective nuclear charge will decreases, by that the atomic size or ionic radii will increase. This is about atomic and ionic radii. This is overall p block elements, see here, and this is boron family, this is carbon family, this is nitrogen, this is oxygen, fluorine, and this is overall noble gases. This is halogens, this is chalcogens, this is pnictogens. Okay, here metals, metalloids and non-metals also you can observe from group 13 to group 18. Next, ionization enthalpy. Ionization enthalpy of p block elements increases along a period and decreases down the group. Ionization enthalpy means what? The removal of electron from the outermost shell or valence shell. So, in the p block elements increases along a period. Along a period means from left to right, the ionization enthalpy will increases, okay, and decreases down a group. Electron affinity. Along a period, electron affinity of p block elements increases from left to right due to decrease in atomic size. Electron affinity means the attraction of one electron to nucleus. So, due to atomic size decrease along the period, so what will happen? The affinity towards the electron is more. Down a group, electron affinity decreases due to increase in atomic size. Down the group, atomic size will increase, so electron affinity will decrease. Next, electronegativity. Okay, the pull of electrons. Electronegativity of p block elements increases along a period and decreases down the group. Decrease is due to the increases in atomic size. We know one concept that when that is from left to right, size decreases but electronegativity increases. That electronegativity is nothing but pull of electrons towards the nucleus. As the atomic size decreases, the distance between nucleus and the external electron will be more. So, it will get attracted very easily, by that electronegativity will increase. But down the group, vice versa will happen. The main reason of electronegativity decrease or increase due to the atomic size. Next, metallic character. Metallic character decreases along a period and increases down the group. We have seen that first S block elements are metals, D block elements also metals. In P block, half of the metallic character we have seen. That means from left to right of the periodic table, metallic character decreases, but down the group metallic character increases. The increase in metallic character down a group is due to the increase in atomic size and decrease in ionization enthalpy. Why this will happen according to down the group? This will happen due to increase in atomic size and decrease in ionization enthalpy. So, the metallic character will keeps on increased. It is interesting to note that the non-metals and metalloids exist only in the P block of the periodic table. It is very much interesting topic that all metals, metalloids, non-metals will exert or will exhibit, all are present in only in the P block elements. Metals you know, non-metals also you know. The metalloids are the elements which act or which exhibit the characteristics of both metallic nature and the non-metallic nature. The non-metallic character decreases down the group. Next, oxidation states. The P block elements exhibit a variety of positive and negative oxidation states. The maximum oxidation state formed by P block elements is 1 to 10, where X is the group number. It is group oxidation state. The group oxidation state sometimes attributed to the inert pair effect. The occurrences of oxidation states 2 unit less than the group oxidation states are sometimes attributed to the inert pair effect state. The relative stabilities of these two oxidation states, that is group oxidation state and 2 unit less than the group oxidation state, may be vary from group to group and will be discussed at appropriated places. Okay, oxidation state based on the group number. And P block elements will show a variable oxidation states also. Group 13 elements, boron family elements. We'll see some of the properties of group 13 elements, that is boron family. The boron family contains the non-metal boron and metals aluminium, gallium, indium and thallium. Generally, boron group elements do not occur elementally in nature. Usually, this boron family or elements will not occur elementally in nature, are scarce in nature except aluminium, which is the most abundant metallic element. Except aluminium, all will be traces. Have 3 valence electrons. All the elements will having 3 valence electrons. Are metallic except boron, which is a solid metalloid. Except boron, all elements which are present in boron family are metallic in nature and are soft and have low melting points except boron, which is hard and has a high melting point. Other elements are soft and having low melting point except boron. Boron is very hard and it needs high melting point. And they are chemically reactive at moderate temperature except boron. Because boron is a metalloid, it is having exceptional cases. Aluminium is the most important metal in the boron family. This element is the most abundant metal in the Earth's crust. 7.5 to 8.4%. Aluminium is the third most abundant element in the Earth, that is 8.3%, after oxygen, that is 45.5%, and silicon 27.7%. In the overall boron family, aluminium is the most important metal in the boron and also abundant metal in the Earth crust. Okay. Next, properties of boron family, that is electronic configuration. The valence shell electronic configuration of boron series elements Ns2Np1. 3 valence electrons will be present, we have discussed. That is how boron symbol B, after helium 2s2 2p1, aluminium Al, neon 3s2 3p1, gallium Ga, after argon 3d10 4s2 4p1, indium iron, after krypton 4d10 5s2 5p1, thallium Tl, after xenon 4f14 5d10 6s2 6p1. We have told that while going to the highest atomic number elements, there is a influence of D and F electrons. See here, moving to down the elements, here D electrons will reach, here F electrons will having. So here influence of D and F block elements influence will be present. Next, atomic and ionic radii. The atomic and ionic radii of group 13 elements increases on moving down the group. Down the group, atomic size and ionic size will increase due to the addition of new shell. But the observed atomic radius of aluminium 143 picometer is slightly more than that of gallium 135 picometer. This can be understood from the variation in the inner core of the electronic configuration. So, inner core electronic configuration is little bit different due to the influence of D and F electrons. We know that due to that variation, what we have seen here, aluminium, after aluminium, gallium is present. Its atomic size should be more, but aluminium will get 143 picometer, later gallium will get 135 picometer. There is some changes which is not according to the periodic trends which is followed in the periodic table. This is why means due to the variation in inner core electronic configuration of p block elements. Next, ionization enthalpy. The ionization energies of boron series of elements decreases or moving down the group. Ionization energy of boron series of elements decreases or moving down the group. This is due to the increase in atomic size, screening effect which lowers the effect of increased nuclear charge. As atomic size will increase, screening effect will also get increased. So, this is increases with nuclear charge. Consequently, the electron becomes less and less tightly held by the nucleus as we move down the group. New shells will be keep on adding. So, the influence between the nucleus and the external electron will be less. Hence, ionization energy decreases down the group. Ionization energy decreases sharply from boron to aluminium, and then the ionization energy of gallium is unexpectedly higher than that of aluminium. This trend again you have to know that because of the inner core electronic configuration. Next, electronegativity. Electronegativity decreases from boron to aluminium and then increases. This is due to the variation in atomic size. Okay, electronegativity decreases because atomic size will increases down the group boron to aluminium, but due to variation in atomic size it will also little bit changes. These are the periodic trends of boron family. In the next class, we'll see about physical and chemical properties of boron family, anomalous behavior of boron, important compounds of boron. Okay. I hope you have understood completely whatever I have taught today. We'll meet in the next session. Thank you.